So today, our group are going to do the Technique in Food and Nutrient Evaluations practical test, and we are from Group 3. Let me introduce my member. First, I'm Malvino, and next here is Celine.
Hi, Dr. Neo.
And next is Corine.
Hi, Dr. Neo.
And last but not least, we have khai.
Hi.
Okay, so today we are going to do the HPLC, which is a high performance liquid chromatography. So HPLC is one of the technique in analytical chemistry, where we are going to separate and find out what compounds are there in the mixtures of solutions or whatsoever. And not only to determine which compounds, we can also detect its concentrations and its retention time. So today the hypothesis of our experiment is, here we are given a T, right, T. So hypothesis says that this T should contains around approximately 11 milligram over 100 grams of caffeine. And today the HPLC that we are going to do is a reverse phase, because we are going to extract the caffeine, and caffeine is a polar, hence we are using a non-polar stationary phase, which is C18, and the polar mobile phase, which is the mixtures of methanol and water. So as you can see here, we are given the volumetric flask, and then of course this is the sample, and this is the mobile phase, yes, and some beaker and also micro pipette. So if you are curious with what we are going to do, keep watching and see you later.
The objective of this practical is to quantify the concentration of caffeine in black tea by using HPLC. So the problem statement of this experiment is determination of the concentration of caffeine in black tea by using HPLC.
Now procedures of sample preparation will be illustrated. Firstly, tea sample is diluted. 0.5 ml of prepared tea was pipetted into a 50 ml volumetric flask. And diluted by using mobile phase of methanol and water in 1:1 ratio. The mixture is topped up to the mark of the volumetric flask carefully by using water dropper to avoid overshot. The volumetric flask needs to be shaken to mix the sample with mobile phase thoroughly. Moving on, standard solution which will be used to generate the standard curve was prepared. 100 ppm of standard stock solution is given, and it is diluted into 2, 4, 6, 8, 10 ppm by using the mobile phase. The calculation is shown as such. To prepare 2 ppm of standard solution, 1 ml of standard stock solution is pipetted into 50 ml volumetric flask. And top up to the mark of the volumetric flask by using the mobile phase. The volumetric flask needs to be shaken to mix the standard solution with mobile phase thoroughly. Other concentration of standard solutions are prepared likewise by using different volume of standard stock as shown in the calculation just now.
1, 2, 3, 4, 5. Now, the diluted tea sample is filtered by using the filtration syringe to remove all impurities to avoid the clogging of the system of the HPLC, so that the machine won't be killed. All of the sample and standard has been moved to the wire tube, and now all of them are ready and sealed in the instrumentation room. Stay tuned with us.
We are heading to HPLC instrument room to perform HPLC analysis. Good luck!
We are already in the HPLC system. Wow, such an expensive system. Wow. So here are the mobile phase reservoir, you can see, we have the communication bus module, and I think this is the detector. We have the photodiode array and refractive index 2-in-1, but I think today we are going to use the PDA as we are going to determine caffeine, and photodiode array detector can measure simultaneous wavelength in one go. That's why we use this. And then another important thing is the auto centrifuge, where I'm going to open it, and this is the sample valve. So actually, as you can see, you don't have to really pull it out. 3, 4, 5, 6. So later, when we put in the sample here, we have to also adjust the labeling in the computer accordingly.
We put in the standard one accordingly. Sample 2, standard 2, standard 3, standard 4, standard 5, and last put in the sample. So now write the standard name.
We are using all 5 standard caffeine stocks, so their retention time will be approximately the same as can be seen from the result before. So after finishing the HPLC analysis, we get 4 results from the sample because tea does not only contains caffeine. So how can we know whether the one that we take out is caffeine? It's from the retention time, where the retention time is approximately the same with the one in the standard, so that one will be chosen for us to interpret the result. The standard curve of the caffeine that we obtain from the HPLC analysis through Microsoft Excel shows that this obeys the Peirce law, where if we increase the concentrations of that particular solutions, it will also increase the absorbance. But in this case, because we are using the HPLC, we are measuring the area under the peak instead of the absorbance. So since we get a linear regression line, so everything is fine.
After that, a standard curve of caffeine is generated, and the calibration of standard curve using known sample concentration is important because it can show the linear relationship between the absorbent units and the analyzed concentration. The equation of the standard curve, this one, can be used to calculate the concentration of analyzed in a sample by interpolation on the graph.
Action!
Okay, from the standard curve, we know that the equation is y equals to 9977.2x. And from the HPLC analysis, we know that the AU of our sample is 22428. And this is actually our y. So in order to know the concentration of our sample, which is x, we have to start 22428 into this equation. So our answer of concentration, which is x, will be 2.2479 ppm. However, this is not the final concentration of our sample because we diluted 0.5 ml sample into 50 ml of mobile phase, which contributed to a dilution factor of 100. Therefore, we have to times 100 by using this answer in order to get 224.79 ppm, and this one is our final concentration of our sample. However, we have to convert ppm, the unit here, into mg per 100 g. So, in order to convert ppm to mg per 100 g, we divide this value, 224.79 ppm, with 10. And then we got our ultimate final answer, which is 22.48 mg per 100 g. And this is the final concentration of our sample.
So in conclusion, the hypothesis is rejected. The caffeine concentration found in this experiment is 22.48 mg per 100 gram. There was an overestimation from our experimental result. However, according to USDA, the concentration of caffeine in black tea is actually 20 mg per 100 gram, which is very close to our experimental result. The variance between experimental result with the caffeine concentration in the question is due to different brand of black tea used in two experiments. Besides, human errors such as improper sample dilution preparation can cause the overestimation of the experimental result also. For example, the mobile phase didn't being topped up until the mark in volumetric flush and slide over pipette of sample T prepared into the volumetric flush.
So here is the end of our video. If you like, don't forget to leave a like, comment and subscribe. And lastly, for Dr. Neo, this is from group 3 in the practical. So we would like to thank you very much for making this very hard module become simple. We can feel that you really put your effort in teaching us. So
Thank you, Dr. Neo.
thank you for everything.
Thank you.
Bye-bye.